A single, bright spark ignites. Energy is nothing without direction. Fast, rhythmic cuts, conveyor belts, trains, pumps, city lights. Every day, billions of kilowatts are consumed to keep heavy industry moving, but we rarely see the machine responsible for it all. The blur stops instantly. Total silence. Fade into the clean gray studio background to reveal the unsung hero of engineering. Meet the workhorse of modern industry, the robust and reliable three-phase induction motor. To understand the mechanics, we float the parts apart. This reveals the two most critical elements, the stationary stator ring and the spinning rotor suspended inside it. Up close, you can see the copper coils wedged into the iron core. This specific geometry directs the magnetic flux, transforming raw electrical energy into the force needed for rotation. Unlike the stator, this rotor has no direct electrical connection. Current is induced into these aluminum bars by the magnetic field, creating the powerful torque that spins the steel shaft. Here we see the physics of electromagnetism. The blue flux lines rotate around the stator, creating a torque that pulls the rotor, converting electrical energy into mechanical motion. This interface visualizes the slip. The magnetic field must cut across the rotor bars to induce current. Therefore, the rotor must always spin slower than the synchronous field to maintain its power. Proper cooling is vital. As you see here, the fan pushes air along the metal ribs. This pulls heat away from the core, ensuring the internal temperature remains within safe operating limits. This is the terminal box, where the power enters. By arranging these brass links in specific patterns, like this delta configuration, we adapt the internal windings to match the facility's voltage supply. Modern motors rely on pulse width modulation. The drive rapidly switches voltage to mimic a perfect sine wave. This allows the induction motor to run efficiently at any speed we choose. In the end, the physics comes to life here. Driving heavy conveyors day and night, the induction motor remains the silent, unsung hero that powers the entire backbone of our modern industrial world. Deep inside the housing, we find the bearings. Notice the golden grease packed between the steel balls. This lubrication is vital. It prevents metal-on-metal contact and ensures smooth, silent operation. Cooling is simple but vital. The plastic fan pushes air along the metal ribs. This thermal exchange dissipates waste heat, ensuring the motor survives continuous operation. Finally, the cooling system. The fan drives air along the metal casing fins. This simple heat exchange lowers the internal temperature, ensuring the insulation lasts for decades of operation. If you enjoyed this visualization of the induction motor, please hit the like button. It helps these animations reach more engineers. And don't forget to subscribe for next week's deep dive into industrial mechanics.